Okay, welcome back. This is a continuation of 2.2, definition of limits. These are the notes. We talked about two-sided limits, and now I want to talk about one-sided limits. One-sided limits are pretty important for the definition of a two-sided limit. We can't really have a two-sided limit without a one-sided limit, so I kind of just want to talk about something here. I'm going to give you two different examples of limits, and we'll kind of take a look at these for a second. I'm going to call this my x-axis, call this my y-axis, and I'm just going to put a number here like 2 and then 3, okay? And here's what I'm going to do. I'm going to put a point here at 2, 3, and I got a function that goes like this, okay? So I got this point on the graph. So here's what I'm going to talk about. When I talk about one-sided limits, I can express a limit. Let's say that x approaches 2, and I'm going to say from the right. If I use the little plus sign, this means from the right. So from the right, okay? And I'm going to call this function f of x. So the limit as x approaches 2 from the right of f of x is going to equal, so if we approach from the right, it's going to be 3, okay? Now, if I do the same thing and I say, okay, well, let's talk about the limit as x approaches 2 from the left. So when I use that little negative sign, that means I'm coming from the left. And I go, okay, so what am I approaching, what y value am I approaching when I approach 2 from the left? And so that gives me the same thing. So limit as x approaches 2 from the left of f of x is equal to 3, okay? So now, what you can see here is that the right side limit and the left side limit are the same. That means that the two-sided limit, the limit as x approaches 2 of f of x, is equal to 3, okay? And we kind of just know that because that's what we just did in, previously, in those previous videos. So, but let's take a look at another one, okay? Let's say that we have a graph that jumps. All right, I'm going to change colors here. Let's say that I've got a y-axis and an x-axis. I'm going to call this x, call this y. And I'm going to look at the value, the x value of 2, okay? I'm going to call this the y value of 2 and this the y value of 4. Okay, this isn't drawn to scale, but you get the idea. All right, and I've got a point here, and I've got a function that goes like this. All right, and then I have this jump up here where it's not defined here. I have a hole here, but our function continues on. Okay, so what I want to do is I want to talk about the limit as x approaches 2 from the right. What's the right side limit doing? Okay, and so as I approach the right side, as I approach 2 from the right, what y value, I'm going to call this g of x, what y value am I approaching? Okay, so the limit as x approaches 2 from the right, I'm approaching the y value of 4. So this is equal to 4, okay? Now, I could ask the other question and say, what's the limit as x approaches 2 from the left of g of x? Okay, what's going on as I approach from the left? What y value am I getting? Well, I'm getting a y value of 2, okay? So these two limits don't agree, okay? They're not approaching the same y value. So if I were to ask the question, what's the limit as x approaches 2 from the two-sided limit, okay, of g of x, because these don't agree, the two-sided limit does not exist. And we kind of talked about that initially, but this is the formal definition. This is kind of what I want to talk about. And so the conclusion that we can make here is that two-sided limits exist if the one-sided limits agree. If the one-sided limits agree. And when I mean that they agree, that means that they are the same, okay? And if you're like me and you want to put this into terms that everybody understands, instead of saying that they agree or they're the same, you can say that they are approaching the same math party, okay? Approaching the same math party, okay? So hopefully this makes a little bit of sense to you. Let's look at some graphs to try and solidify this. Okay, so let's take a look at all this, all right? So we've got function values, we've got one-sided limits, we've got two-sided limits. So let's see what we've got here. Okay, so it wants to know what's g of 2. What's the point on my graph when x is equal to 2? And that's 3. Okay, that's where my point is. So g of 2 is equal to 3. That's just a point on the graph. Okay, what's the limit as x approaches 2 from the left? So as we approach 2 from the left, what y value are we approaching? And that's 2. Okay, what happens if we approach 2 from the right? And if we approach 2 from the right, we're actually approaching 3. Okay, these two one-sided limits do not agree. They're not the same. They are not going to the same math party. So the two-sided limit doesn't exist. Okay, all right, they're not approaching the same value. They're approaching different values, so that doesn't exist. Okay, all right, let's take a look at g of this next one, looking around at x equals 3. So what's g of 3? Okay, if we plug in 3 into our function, what do we get? Well, we actually get 2. Okay, that's where my point is. So we get 2. Okay, what's the limit as x approaches 3 from the left? So if we approach 3 from the left, we're going to get 3. Okay, as we approach 3 from the left, we're going to get 3. All right, if we approach 3 from the right, what are we approaching? We're actually approaching the y value of 2. Okay, and then it wants to know, okay, well, what's g of 4? Okay, so if I plug in 4, what's going on there? That's the y value of 3. Okay, and it wants to know what's the limit as x approaches 4 of g of x, and we are approaching 3. Okay, so hopefully that makes sense if you look at this from the graph. Okay, if you need to rewind and rewatch that to see how I do that, please do. Okay, all right, let's do this again. Different graph, another function g. So g of -1, what's that? Okay, g of -1, the point on my graph is at 2, or I'm sorry, it's at 3. Okay, so this is 3. Okay, what's the limit as x approaches -1 from the left? So as we approach -1 from the left, we actually get a y value of 2. Okay, as we approach -1 from the right, we're also approaching 2. Okay, and so then it says, okay, if the two-sided limit, if the one-sided limits agree, if they're the same, if they're approaching the same math party, then the two-sided limit exists, and it's going to be the same thing. It's going to be 2. Okay. All right, let's move on. Okay, it's asking what's g of 1. All right, g of 1 is 2. Okay, that's where my point is on the graph. That's 2. Okay, the limit as x approaches 1, what's going on? Okay, so as I approach from the left, I'm approaching 4. As I approach from the right, I'm approaching 5. Okay, these do not match up. I'm not going to the same math party. I'm not approaching the same y value. This limit does not exist. Okay. All right, let's take a look at 3. So 1, 2, 3. Here's 3. Okay, if we approach from the left side, I'm approaching 4. As I approach from the right side, I'm approaching 4. So this is equal to 4. Okay, what's g of 5? G of 5 is 5. Okay, that's the point on the graph. As we approach 5 from the left, what are we approaching? We're approaching 5. Okay, so guys, it's just a lot of just looking at the graph, knowing what the question is asking you. Okay, being able to read this and being able to say, okay, what is this asking me? Identify what it's asking you, answer the question, and we're good. Okay, if you guys have questions, write those down. Okay, this is kind of some brand new stuff for you. The most commonly asked question is this the same stuff that's being asked in that Lindsay Lohan movie? And yes, where she makes that claim that the limit does not exist. So if you want to scream out, the limit does not exist, the limit does not exist, you can sure do that, just don't do it very loudly, and please don't do it during an exam. That's just not fun for anybody. So, all right, guys, I had a great time with this. Hope you did too. We'll see you.